Okay, in section 7.4, we are going to be adding and subtracting fractions that do not have common denominators. So we will be getting a common denominator. Although the questions are all listed here, I'm going to go ahead and go down and work in blank space because these problems, they're going to take some room to do. All right, problem number 1. It will say something like perform the indicated operation. So either add or subtract, whatever is appropriate. So I have 16 over 4y plus 9 over 3y. Now I know that many of you are used to doing your addition and subtraction of fractions by writing the problems in a column vertically. With algebra fractions, we almost always write them horizontally. So I hope you can tolerate this. All right, first thing you need to do is find the least common denominator because these are not the same. These are monomials, so just think regular old numbers. What would you need for a 4 and a 3 to both go into? 12. So my LCD will be, I need a 12. Do you agree that I also need y? And I don't need y squared because neither of these was y squared. So I need just 12y. So I'm going to write down 12y for that denominator and 12y for that denominator. What I'm doing now, next, is working with a fraction and the fraction below it to create that equivalent fraction. This fraction with the fraction below it. So here I go. I'm going to compare old to new. What was 4y multiplied by to turn it into 12y? 3. So if the bottom was multiplied by 3, then the top must be multiplied by 3. What is 3 times 16? 48. So I take old, compare it to new, find the missing factor, and multiply it times the top. Let's do it with the second fraction. Compare old to new. What was 3y multiplied by to turn it into 12y? 4. So if the bottom was multiplied by 4, then the top needs to be multiplied by 4. And 4 times 9 is 36. Is everybody okay? I have found the least common denominator, built the equivalent fractions. Those are skills that I learned back in 7.3. Now, I have a common denominator, so I'll take and write down the 12y, and it's going to be 48 plus 36. You may choose to skip that step. I also did that one in 7.3, and if I add them together, what do I get? 84 over 12y. And your last step is to always ask yourself if you can reduce. And do you think there's something that goes into 84 and 12y? Yeah? 12 does. 12 goes into itself once. 12 goes into 84 7 times. And my final answer is 7 over y. We used all of the skills from 7.3. We found a common denominator. We built equivalent fractions. We had two fractions with a like denominator. We added them, and then we reduced our answer. So everything you learned in 7.3, you just used in one problem. Let's look at number 2. I have 12a over b minus 7b over 3. The first thing I need to do is find the least common denominator. What will the LCD be? I heard somebody say it. I need a 3 and I need a b. It's 3b. You need one of every different kind of factor, and there are no exponents here. So for the first fraction, I need a 3b, and for the second fraction, I need a 3b. I compare old to new. What was b multiplied by to turn it into 3b? 3. So multiply the top by 3. What is 12a times 3? 36a. The second fraction. What was 3 multiplied by to turn it into 3b? b. So you have to multiply the top by it, and what will you get? 7b squared. I have the same denominator, so I'll write it down one time, and I have 36a minus 7b squared. The final question I ask myself is, can I reduce? Well, can you factor the numerator? Because it's a binomial, so can you factor it? There's no common factor. It's not the difference of squares, cubes. I would say no, you can't factor it. And if you can't factor it, then don't think you can reduce it, because you can't. Done. You had a 7b up here. The missing factor was a b. So I multiplied 7b times b. That gave me 7b squared. Now, here's a common mistake. People will look at this and say, oh, but wait a minute. I've got a 3 down here and a 36 up here. Why don't I do that reducing? Because that's 7b squared. 3 is not a factor of the entire numerator, so you can't just touch one of its terms. It's all or nothing. Okay, let's look at number 3. I have 7 over x plus 5 over 6x squared. Step number 1, find the least common denominator. Well, there's no factoring that needs to be done. I just need to look at those. What will the LCD be? 6x squared. I need the 6. I need the x, but I need an x squared because I need the high power. So each denominator will be a 6x squared. What's the new factor? What has x been multiplied by to turn it into 6x squared? 6x. And if you do that to the numerator, what's 6x times 7? 42x. Second fraction. What was 6x squared multiplied by to turn it into 6x squared? 1. In other words, the identity. So no change in the top. It will stay a 5. So if this old denominator was the new denominator, then the numerators don't change. That gives me 6x squared for a common denominator. And what will the two numerators, I'll add those. 42x plus 5. Anything happen? No, those are not like terms. Can you factor the binomial 42x plus 5? No. Done. Find the common denominator. Build the new numerators. Do as much addition as you can. Check and see if you can reduce. Okay, let's look at 4. I have 8 over x plus 1 plus 15 over 5x plus 5. Now this problem takes a little bit of a different turn because these denominators are no longer monomials. They are binomials. Can I factor the denominator of the first one? No. Can I factor the denominator of the second one? Yes. Do you see a common factor of 5? So that's 5 times x plus 1. So I don't need that form anymore. I'm trying to build the least common denominator. That's why I factored. What will the least common denominator be? I need a 5, and I need an x plus 1. So I'll write it down twice, 5 times x plus 1. Another fraction, 5 times x plus 1. It's time to compare. Compare the old to the new. What was this original denominator multiplied by to turn it into the new one? 5. And if the bottom was multiplied by 5, then the top needs to get multiplied by 5. 8 times 5 is 40. Second fraction. What was the old denominator multiplied by to turn it into the new denominator? A 1, which means no change for that top. The step that most people don't want to mess with, I'm going to take 40 plus 15 over 5 times x plus 1. Whoops. That gives me 55 over 5 times x plus 1. What's the last question? Can you reduce? Do you see a common factor? 5. 5 goes into itself once. 5 goes into 55 11 times. My final answer is 11 over x plus 1. So this problem had all the steps, including the reducing. All right, problem number 5. Let's look at 5 over x plus 4 minus 4x over x squared minus 16. Now I know that you might not have realized it, but this is the first of these problems that is subtraction. And you have to be so very cautious when you're doing a subtraction. All right, I won't worry about it just yet because I have to find an LCD. Can I factor the first denominator? No. Can I factor the second denominator? Yes. Do you agree that's the difference of squares? So that's going to be x plus 4 and x minus 4. What is my LCD? I need an x plus 4 and I need an x minus 4. Do I need anything squared? No, because there was nothing squared in either one of the denominators. So I need one of every different kind of factor. I have an x plus 4, got to represent it. Got an x minus 4, got to have it. X plus 4, x minus 4. Whoops. Minus sign. X plus 4, x minus 4. All right, comparing. Look at the old denominator, look at the new denominator, and tell me what the new factor is. X minus 4. And what do you, now I know that y'all like to skip as many steps as possible, but I'm a little concerned about some things. So now that it's getting more complicated, when I have to multiply 5 times x minus 4, I'm just going to write it down and I'll distribute it in a minute. If you want to do it in your head, that's fine. Going on. What's going on here? What has the old denominator been multiplied by to get the new one? 1. So no change in the top. It's 4x. So although you might think I'm really just doing steps that I shouldn't have to do, I have x plus 4 times x minus 4, and I have 5 times x minus 4 minus 4x. I want you to be very careful in simplifying the numerators that have been put together. I've got distributive property. That gives me 5x minus 20, and I have minus 4x over x plus 4 times x minus 4. I know that these problems get very long to write down, especially since I write down every step you ever thought about having. All right, when I finish simplifying that numerator, I have 5x minus 4x, which is x. I still have a minus 20, and it's over x plus 4 times x minus 4. Is there anything I can simplify there? I mean, can I factor it? No. Then I'm done.
I have a question.
Yes.
I know earlier you said whenever you subtract the fraction or whatnot, that you have to make sure you connect it negative to the numerator.
Yes.
Why didn't you do that like on the 3 steps back to the 4?
Oh, okay. You can do it way up here if you want to. So let me address what she's saying. I'm going to use a color to do it. I could have said, I said I was going to use a color. I could have said that's plus a negative. You could have changed that. Now what you might be thinking about was when I did opposites. I think that was it. You could have done this, and you can see that it ended up being negative down here later. I just waited and did it right here. So I think maybe you were thinking about the opposite problem. All right, let's look at number 6. If you were to look at these, I have problems 6 through 10 on a separate page, so I'm going to keep on going. Problem number 6. I have 4 over f minus 2 plus 8 over 2 minus f. It's quite coincidental that you just asked that question, and now we run into a problem that actually has some opposites in it. All right, I need to find the least common denominator. And I hope that you see immediately that this is a pair of opposites. So what will we do? Don't we change one of them? Okay, I don't care for this one. So I'm going to change it to f minus 2. So now I have done an opposite. What do I have to do so that I have not changed the problem? I need to change something else. Now, here's something I want to throw in. I usually change the numerator. But do you remember there are 3 spots? There's the bottom, the top, and the sign out in front. If I need to change the bottom to its opposite, the only time I ever change this instead of the top is if it's a subtraction. And I don't like subtraction very much, so I'll change it to addition. And I don't think that's going to happen to us in any of our problems. But usually, I'll change the bottom and then I'll change the top. But I might change this one instead of the top if it's a minus. I could turn it to a plus and make the problem easier. Okay, I should be in good shape now because I have a common denominator already. I have f minus 2, and all I have is 4 plus negative 8. What is 4 plus negative 8? Negative 4 over f minus 2. There's no factoring. Can I do some reducing? No, because remember the f minus 2, although it might not be in parentheses, it is a binomial. You cannot touch the 2 of it It's all of it or nothing. There is my difference. Let's look at 7. I have 5 over m plus the whole value 2. What do your instincts tell you to do first? Put it over 1. Okay, and now it's time to find a common denominator. What's the common denominator of those two denominators? Just m. Because what's m times 1? M. So my common denominator is m. Once you get the common denominator, then it's time to build the equivalent fractions, and I'm going to do my comparison. What has m been multiplied by to get m? 1. So 1 times 5 is 5. Comparing the second one. What has 1 been multiplied by to get m? By m. And then 2 times m is 2m. Okay, it seems like we're back to a super easy problem, and we are. The whole purpose of this problem is what did you do when that started out as a whole value 2, and you already knew. Keep the m. I have 5 plus 2m as a numerator. I can't factor. Can I reduce? No. Could I mark out the m's?
No.
No, because this binomial is an entity that needs to stay as an expression. Questions? Okay, let's look at number 8. I have 1 over x plus 8 minus 7 over, and this is already factored for us, x plus 8 quantity squared. All right, no factoring to be done. I just need you to tell me what the least common denominator will be. X plus 8 quantity squared. I need the squared one. All right, so I need x plus 8 squared, x plus 8 squared. It's time to compare old to new. What do you have to multiply x plus 8 by to get x plus 8 squared? Yes, I need an x plus 8. When I multiply it times the top, 1 times x plus 8 gives me x plus 8. So that was easy. Second fraction. What do I have to multiply x plus 8 squared by to get x plus 8 squared? 1. So multiply the top by 1, and it's going to be a 7. It is, by the way, a subtracted 7. So I have x plus 8 minus 7 all over x plus 8 quantity squared. Combining like terms, that gives me x plus 1 over x plus 8 quantity squared. Can I do any more factoring? No. Can I do any reducing? No. Yes. I had an x, so that x is down here, and then I had a positive 8 and a minus 7. So it was 8 minus 7 gave me the 1. All right, next problem is going to be a little bit longer. Number 9. I have 4x over x minus 7 minus 2x over x minus 2. Can you factor either of those denominators? No. So x minus 7 is All I can do with that, and x minus 2. What is the common denominator, the least common denominator?
2x.
Don't add them, but multiply them, and don't figure out what it is. It is x minus 7 times x minus 2. I need one of each. X minus 7, x minus 2. I need one of each different kind of factor, and there were no powers. You ready to compare? What was x minus 7 multiplied by to turn it into this new denominator? What's the new factor? X minus 2. It used to just be an x minus 7. Now it's an x minus 7 times x minus 2. You're going to multiply that times the top, and I'm not going to multiply it just yet. I'm going to write 4x times x minus 2, and I'll multiply it out in a minute. Second fraction. What changed from the old denominator to the new denominator? X minus 7. So multiply the top by the x minus 7. You'll have a 2x times an x minus 7. Does everybody see where everything came from? Now, I'm doing a step, might be useless, but those have a common denominator, so I write the denominator once, and I have 4x times x minus 2 minus 2x times x minus 7. All I did was write that with one denominator instead of two. Now, distributive property. The numerator, 4x times x is 4x squared. 4x times negative 2 is negative 8x. What am I distributing to the second group? Negative 2x. It was a subtraction problem, so you really want to be aware of that. So negative 2x times x is negative 2x squared. Negative 2x times negative 7 is positive 14x. And if I was going to pick one place to find a mistake in somebody's problem, it probably would have been this sign right here. So I have x plus, no I don't. I have x minus 7 times x minus 2 for a denominator. All right, I had the common denominator, I did all the products, so now I need to see if I can combine like terms. I have a 4x squared and a minus 2x squared for how much? 2x squared. I have a minus 8x and a plus 14x for plus 6x. And it's over x minus 7 times x minus 2. Okay, getting tired.
So that you just combine like terms?
Yes, ma'am. So back up here, I had same denominator. When I put it all together, now it becomes simplifying the numerator. And I did my distributive properties, and then I combined my like terms. So now it's time to ask that final question, can you reduce? And you can reduce only if you can factor the top and have a common factor. Can you factor the top? Yes. There's a common factor of 2x. 2x goes into the first term, x times. 2x goes into the last term, 3 times. And that's over x minus 7 times x minus 2. I did factor. Did it help me reduce? What can I cancel out? Nothing. Now this is a little frustrating. If you factor and it doesn't give you a common factor, then you don't even show that you did that. The rule is factor only if it's going to give you a common factor. But I would argue that you don't know until you actually go through the factoring. So we went through, we did the factoring. It did not create any common factors. So I say, oh, never mind. I didn't really even need to do that. I'm back to this. Now, if you were taking a paper pencil test for me and you wrote this as an answer down, it would be absolutely fine. MathLab has this as its answer, and I don't know if it would give you credit for this. So the rule is, show that you factored only if it leads toward reducing. And if it doesn't lead to reducing, then don't bother to show that you ever did it. Yes?
Why did you get it this way? Why did you get it 2x? 2x?
This 2x,
Yes, ma'am.
it was right up here. It was the numerator. So when I asked myself the question in the comparison step, what do you have to multiply x minus 2 by to get this? Y'all told me x minus 7. So I need to multiply x minus 7 times what's up here. There's the 2x. There's the x minus 7. Okay? All right, let's go to number 10. We have x over x squared minus 1 minus 1 over x squared minus 2x plus 1. I need a common denominator. In order to do that, I need to factor these. What technique can I use to factor the first one? Difference of squares. That's going to factor into x plus 1 times x minus 1. I'm going to factor the second one. It's a trinomial, so I'll go with trial and error. I need a minus and a minus. I need an x and an x. How about x minus 1, x minus 1? What is the safest way to write this? X minus 1 squared, so that I won't forget an exponent. So those are my final forms. So I factored the first one as a difference of squares. I factored the second one. Maybe I didn't notice it was a perfect square trinomial, but it was. Same factor twice, write it as a factor squared. Common denominator. I need one of every different kind of factor, high power. So I need an x plus 1. I need an x minus 1. But what power of x minus 1 do I need? Second power. So I'll write that down again, x plus 1, x minus 1 squared. I have the x plus 1, and I had x minus 1s in both of these, but I write down the one with the high power. All right, now it's time to compare. Look at the old, look at the new. What is the new factor down here? An additional x minus 1. So I'm going to multiply the x that's already up here times an x minus 1, but I'm just going to leave it to multiply in another step. It's x times x minus 1. In the second fraction, comparing look at the old, look at the new. What's the new factor down here? X plus 1, because it had an x minus 1 squared, but it didn't have an x plus 1. So I need an x plus 1. Multiply the x plus 1 times the numerator. It's going to be 1 times x plus 1. A little silly for me to write the 1, but I did. Now that I have a common denominator, I can write it just one time. X plus 1 times x minus 1 quantity squared. And I've got x times x minus 1 minus 1 times x plus 1. And that was just an activity for copying. It's now time to completely simplify the numerator. I'm going to need to do the distributive property and then combine like terms. I'm going to copy down that denominator. And now to the numerators. X times x gives me x squared. X times negative 1 gives me negative x. What are you distributing to the second group? Negative 1. So made it go away. Negative 1 times x is negative x, and negative 1 times 1 is negative 1. Are there some like terms I could combine? Do you see a negative x and another negative x? So I have x squared minus 2x minus 1 over x plus 1, x minus 1 squared. So it might take you a couple of steps to simplify the numerator. I use the distributive property twice, then I combine my like terms, and I'm down to that final question. Can I reduce? Okay. Can I factor this numerator?
Yeah.
Now, it looks like you can. You'd be very tempted to. Because the last sign is negative, that tells you you're going to have one of each. You cannot get the factors of 1 to have a difference of 2. If this had been a plus, we could have factored, we could have reduced. With that being a minus, you might have to sit and play with it to realize it. This numerator is prime. There's nothing you can do to it, which means there's nothing you can do to any of it. That you can't factor. And it's caused because of that sign. All right, let's look at 11. I have 16 over x squared plus 7x plus 6 minus 7 over x plus 6. And the thing that I'm going to want you to really pay attention to in this problem is what the negative sign causes. Something you could do, if you wanted, you could always, at the beginning of a problem, change it to plus and change all the signs of the numerator. If you wanted to, you could do that, or you can wait and take care of it later. All right, if I need an LCD, I need factors. This second one's already factored. It's just an x plus 6. Can I factor this? Y'all have probably already done it. Last sign is positive, means they're both positive. Need an x and an x. Factors of 6 add up to be 7. 6 and 1. What's the LCD? Yes. I need an x plus 6 and I need an x plus 1. It doesn't matter what order you write them. Because I need one of every different kind of factor, and there were no high powers. Are you ready to compare? Look at the old, look at the new. What has x plus 6 times x plus 1 been multiplied by to get you this? Nothing more than a 1. So multiply the top by 1, which leaves that as 16. Second fraction. What has x plus 6 been multiplied by to get you the common denominator? X plus 1. So if the bottom was multiplied by x plus 1, then the top needs to get multiplied by x plus 1. But you're going to have to be careful because in just a minute, what's going to be the sign on the 7? Negative. All right, so that gives me x plus 6 times x plus 1, and I have 16 minus 7 parentheses x plus 1. You might be tempted to subtract, but you know that Aunt Sally doesn't want you to do that. She likes you to multiply before you do that. So we have 16, negative 7 times x, negative 7x, negative 7 times 1, negative 7. That is where I'm going to find sign mistakes unless you're very careful. So I have x plus 6 times x plus 1 on the bottom. All right, I'm going to write the negative 7x as the first term. Here it is. And then I'm going to combine like terms. I have a positive 16 and a negative 7, which gives me 9 over x plus 6 times x plus 1. You can't see that in class. Can I factor the numerator? No. Done. Now, being honest with you, it takes a lot of forethought to create a problem that is reducible. Because what are the chances that after you do all these steps, you're going to create something that is not only factorable, but has one of these as a factor? It doesn't happen very often. I probably couldn't make one up. All right, last problem. Yes, question. Got it? Okay. The last problem I'm going to do, I'm going to skip all the way to number 13. Whoops, quit that. I'm going to skip to 13, and I'll write it down over here. There are other problems, but we're all getting kind of tired, and I think this will have been plenty of examples for you. All right, 13. We've got x plus 2 over x squared minus 5x minus 36 plus x plus 8 over x squared minus x minus 20. If you're going to find a common denominator, what is each one of you already working on? The factors of these denominators, and they are both trinomials. So that's going to be 1 plus and 1 minus. I need an x and an x. I need factors of 36, which have a difference of 5. 9 and 4. For the second one, I need an x and an x, I need a plus and a minus, I need factors of 20 with a difference of 1. Plus 4 and minus 5. Okay, now there's just going to be a whole bunch of writing in this problem. So I'm getting ready for it. What is the least common denominator? What do I need? I need an x plus 4. I need an x minus 5. and an x minus 9. It does not matter at all what order you write those three factors. Those are the three different kinds of factors. So I need an x plus 4, an x minus 5, and an x minus 9. And now it's time to do the comparison game. Compare old to new. What's the new factor for the first fraction? X minus 5. Which means that you have to multiply the top times x minus 5. Now watch what I write down. I've got x minus 5, and what do I have to multiply it by? X plus 2. In a minute, not right now, but in a minute when I multiply these, I'm going to have to use my FOIL process, not distributive property this time. That's why I chose this problem to demonstrate. Okay? Now, let's look at the second one. Compare. What's the new factor?
X minus 9.
X minus 9. So since the bottom was multiplied by x minus 9, the top needs to get multiplied by x minus 9. So I have x minus 9 times x plus 8. Once again, when I finally get around to multiplying, I'm going to have to use FOIL. So, one big old jumbo denominator of x minus 4 times x minus 5 times x minus 9. And I'm just taking a step to copy. X minus 5 times x plus 2. Luckily, there's a plus sign between them. X minus 9, x plus 8. I'd have to even be more careful if it was subtraction. Oh, thank you. Okay, I had that one miscopied. Thank you. All right, I want to take a second, and I'm going to, I don't know if you'll see it as a different color, but I'm going to do this product that I'm pointing to right now by FOIL, and I'm going to write it right here. The product of the first, x times x, is x squared. The outer product is 2x. The inner product is minus 5x. And the product of the last is minus 10. So in just a minute, I'll bring all that down. All right, over here, I'm going to do this product by FOIL. The product of the first is x squared. The outer product is 8x. What's the inner product? Minus 9x. And the product of the last? Minus 72. Is that okay with everybody? No, but we'll do it anyway. A ton of work. Denominator of x plus 4 times x minus 5 times x minus 9. The numerator is x squared. Is it okay with y'all if I go ahead and combine those? Because normally I would. Minus 3x minus 10 plus x squared minus x minus 72. I combined the 2x and the minus 5x to give me the minus 3, outers plus inners, and then I did the positive 9 and the positive 8 and the negative 9 for negative 1. All right. How do I proceed next? Combine the rest of the like terms. I have an x squared and an x squared for 2x squared. I have a minus 3x and a minus 1x for minus 4x. I have a minus 10 and a minus 72 for minus 82. And it's all over x plus 4 times x minus 5 times x minus 9. And what's the last question? Can you reduce? Well, maybe. The answer has to be right now, maybe. Take this numerator. Let's just go off for just a minute. It's 2x squared minus 4x minus 82. Now that looks factorable to me. Do you see a common factor of 2? So that's 2 times x squared minus 2x minus 41. And I'm thinking that I ought to be looking at trial and error. Whoa. I know I'm going to need an x and an x. I'm going to need a plus and a minus. Now 41. 41 is a prime number. The only way to get 41 is 1 times 41. Does that have a difference of 2? That's all I could do. Would that help me reduce? Is 2 a common factor to the bottom? No. Is this trinomial in the bottom? No. So in other words, I factored a little and it didn't do me any good. So it was another one of those. This is my answer. Remember, factoring is only valuable if it gives you a common factor. All right, please don't put it off. Work on your math lab. I know we just move like there's a freight train running through here, but that's the nature of summer school for us. And we'll call this done.